I don't know where all of you are at, but where we're at, it's starting to storm. So if you hear lightning and see flashes outside, don't be alarmed. If you see us running and screaming from the room, then you can be alarmed.
That's our safety moment.
That's right. That's a safety moment.
Good afternoon, everybody. My name is Joe Crater, EVP of Sales at SPL. We want to welcome you to our webinar on allocation process today. Today, our distinguished panel will consist of Z. Shake, Petroleum Engineer, Bill Terrio, Senior Director of Technology of our Digital Compliance Group, and Dave Curtis, to my right, EVP of Strategy and Technology. The introductory allocation webinar was planned first on purpose because we believe that understanding what components make up an accurate allocation will build the foundation of a solid measurement program. So with that being said, we're planning a series of webinars on measurement. Feel free to let us know along the way if you have any topics you would like to see covered. Our primary presenter is Dave Curtis, and I'll let Dave take it away.
All right, go back to the presentation here. All right, so as we go through this, the system automatically had everybody on mute. So apologize for that. Just for those of you who've been on these types of conferences before, it can get echoey and that type of thing. So we wanted to have the mutes on. If you have questions throughout the thing, there's a Q&A button on your control bar of Zoom. Just click that and send your question at any point. Z's watching the questions and he'll bring it up, make sure that it gets answered. All right, so let's start with allocation. So what is allocation? Allocation is, of course, about everyone getting their piece of the pie. Sounds easy, right? 4 of us at this table. We cut the pie into 4 slices. Everybody gets one. Everybody's happy, right? Well, what if Joe here only provided, 3% of the sugar and 4% of the flour? He's not entitled to the chocolatey goodness in the center of that pie. Unless, of course, contractually, we decided that he did get some of that chocolatey goodness. So it's all about who delivered what into that pie to determine what they get out the other side. So look at that in a little bit more of a box description. Here we have 4 operators contributing to the process, and we've got an oil sale, a gas sale, an NGL sale coming out the other side. So what did each one of those 4 operators contribute? And what do they get of the products that are sold based on everything that's being delivered into that particular process facility? That's what allocation is all about. So as we go through this, again, as Joe mentioned, this is basically kind of an allocation 101. We're going to talk about the principles of allocation and the items that go into it. Later on, we'll likely have a more in-depth allocation series, but this is just the first one to get us all on the same page. So first we have to talk about the responsibilities of you as an allocator. What do you have to provide to the system? So it's all about being fair and equitable. Is everybody getting what they're supposed to in an equitable manner, and something that's not stated on here, in a defensible manner? Because in the end, a lot of this winds up in litigation, and we've got to be able to defend, what each person was paid, what each person was distributed. Okay. You have to research the contributors to any types of balances. You have to identify between theoretical volumes and sales volumes, because there is a difference, and make sure that that's allocated out appropriately. And you have to pay attention to the details which impact that allocation. So you've got agreements, contracts, those can say one thing. Then you can have commingling approvals that change as you go on. And we may have a contract, Bill and I may have a contract with one another that says we're going to allocate in a certain way.
If I'm interested, could you explain what is a commingling approval?
That's a good point. Okay, so commingling approval. So when you measure, when we're out there, we will have multiple different parties coming into a system. Say that can be from multiple different pads going into a gathering system, or on a given pad, you can have fractured ownership on that pad that's all delivering into a single pipeline going into a single facility. So without agreements in place on how those products are going to be mixed together, how they're going to be commingled, we don't know how we can appropriately allocate that back to everybody, or at least in a manner that is agreeable to all parties. And that's where the regulatory group comes in line, because as was mentioned, Bill and I may have an agreement. We're happy with the way we're doing it, but then the government may have a whole different idea. And so I don't know if Casey's logged in yet, but we do have a member of the BLM that's coming on here. And, you know, they want it commingled a certain way. The Texas General Land Office wants it commingled a certain way. And then we as mineral interest owners maybe want it some way different. So we have to find a way to make all parties happy, make sure we're doing it appropriately. Thank you for that question, wherever that came from. We have to ensure that we keep communications between everybody. Open communication is the key to everything, because as your system changes, as allocation rules change, we have to keep that line of communication going to make sure that whoever's doing the allocation understands the requirements of the producers, of the mineral interest owners, of the regulators, all of that. And then, of course, in the end, as an allocator, it's your job to report accurate, equitable, and defensible results to all users. Okay, so let's look at some types of allocations. Product comes from all over the place, and there's a bunch of different types of allocations that go into these varied systems that are out there. So you've got production allocation, and that can be well, property, lease level. It can be down to that single well. It can be for a certain piece of property or at a full lease. Midstream pipeline allocation, so that's where the producer's delivering into a gatherer. That gatherer is transporting that product to some sort of processing facility or gathering facility. That midstream is taking care of that allocation from receipt point to delivery point, right, Bill?
Correct.
Okay. Gathering facilities are bringing the product in from all different locations, taking it in that facility, and then distributing it from there. So there'll be an allocation from there. Gas processing plants, we're delivering into a plant, we're delivering in one or two products, and then multiple other products come out the back door. We're going to talk about what those are in a minute. And we have to know how to process those and allocate them out. And it might not just be as simple as this much was sold and this much was delivered. They have such things in those contracts as, you know, it's based on a fixed recovery through the plant. It's based on actual recovery through the plant. There's all kinds of fun that goes in there. We won't even talk about whether or not you have the right measurement to actually do that allocation. Yes, sir?
We have a question from Brandon. How about BTU allocation?
BTU allocations. Yes, Brandon, you're spot on there. And we're going to talk about that here in a little bit. What we've been talking about kind of implies that we're talking about volumetric allocations, but it's rarely based on just volume, if ever anymore. It's the quality of your product comes in there. So in the case of a gas, you're going to combine your volume with your heating value and get the actual energy, and you're going to allocate that out. Of course, it's not that simple either. Then you have condensate fallout that you have to calculate what the theoretical liquid content of that gas is, so that you can allocate the NGLs and condensate that's being sold out the back door of the plant appropriately to what's being delivered there in the front end. Quality banks, Bill, I'm going to let you talk about quality banks if you don't mind, sir.
Sure. Quality banks, we've administered many of those, but essentially it's taking differences in API gravity, could be sulfur content and NGLs, as you see here, where basically we've got a commingled product being delivered into some kind of separation facility. Ultimately, we're selling, for example, one oil, and that one oil is a certain API gravity. Well, knowing that Joe may have given us 30 API gravity, Z may have given us 45 API gravity, and then we have someone else delivering a 60 gravity. If we're selling 45, then we're spot on. However, we know that through dilution, that API gravities would have been valued differently at the delivery point into the system. So therefore, the attempt of gravity banks is to true up any differences that were realized between what was delivered and what was actually sold at the end of the gathering.
Let you keep going if you will, Bill.
Sure. Multiple allocation techniques that we use are being used across the industry. Of course, we talked about volumetric. We talked about BTU content or energy-based. And we've also have some mass-based systems out there also.
Not enough.
Not enough.
It should all be
That's right.
mass-based, but that's a whole other story.
Component-driven allocations, very, very common when we talk about NGL allocations at the end of a gathering system. All of these use multiple systems whenever we allocate, one of those being process simulation models, in which we can actually build a process simulation model that closely reflects or exactly reflects how the product is being treated on the platform or through the gathering system. We can use those to calculate phase change, model commingling situations where we're commingling different types of fluids into a single gathering system. Single-tiered and multi-tiered environments also do exist, where we would be allocating back to a certain point in an allocation system, and then further using a different methodology possibly to allocate back to other tiers in the system. It's good to note here that all the allocations should be custom designed and fit for purpose. Yes.
I have a question from the previous slide. So regarding quality banks, so it says most quality banks seem to be historically set in the St. James, LA area. Do you see banks yet at Corpus Christi, Texas?
In Corpus Christi, I'm sure. I know of a couple of oil banks that probably exist around those big gathering systems down there. Yes. Could be for sulfur, could be for API gravity. Yes. As I said, allocations need to be fit for purpose, custom designed based on the actual system that you're trying to allocate. It's hard to have an allocation system and say, I'm just going to put it over your process. It's really the other way around. We start with the process and how it's being metered, how it's being commingled, and choose an allocation system and build it for a fit for purpose solution.
Z, you want to tell us a little bit about process simulation modeling, sir?
So when Bill was mentioning phase change, that is typically handled in a process simulation model, what we call a PSM model. So when we talk about phase change, every fluid, let's say gas or liquid, is described by its phase envelope. And when you draw a phase envelope of fluid, you typically need three parameters: pressure, temperature, and the composition. And let's say you change your pressure, and you may be starting with a liquid, but as you drop the pressure, as the pressure drops, you may liberate gas throughout the process as it goes to the sales point. So you have to account for the phase change throughout your process as you go from point of, let's say, from wellhead all the way to the sales. And the process simulation model does a good job of tracking the phase behavior between two fluids as it travels through the process. So in a PSM model, we typically model the gathering facility, or we've been seeing a lot of NGL allocation where we have to model the gas processing plants. And as I said, the PSM model handles the changes in the fluid phase behavior. It enables you calculate oil shrinkage. Now, oil shrinkage is when you start with a volume of oil from, let's say, at a high pressure and temperature, and then when you drop the pressure, and that volume of oil is going to be considerably different from what you first measured. And that is what we call is the shrinkage in oil. And that shrinkage number is used in allocation for oil allocation, which we will talk later. Also, the flash gas that is liberating out of your oil, the PSM can predict that. Theoretical volume calculations. When we talk about theoretical volume, we take a volume of oil or gas, let's say at the wellhead, and we use that composition and we calculate the theoretical volume as the fluid travels all the way to the sales. And that is going to be a theoretical value, what you should be selling. Now that number could be different from your actual sales meter, but that theoretical number is then used in your allocation process. So Bill, do you want to quickly say about fluid analysis verification?
Sure. A lot of times in the PSM, we have different stop gaps that we will observe. For example, we will verify if we're feeding fluid to a bulk separator in the middle, like we show in the diagram here. If we can get a volume and an analysis at that point, then we certainly can verify what the PSM is calculating at that point also, not only on a volumetric basis, but analytically. Yes.
So what you're saying is, just to reiterate, we need a good compositional analysis to plug into this. Very important.
Very important.
Yeah.
Yes.
And the correction, the PSM predicts your theoretical numbers, not the actual numbers.
That's correct. But we would use actual numbers in order to compare to those
Theoretical numbers, correct.
And that would make sure that our PSM is operating correctly.
And that's a good point all the way out throughout the system. When you all are building your allocations, put in checks and balances all the way through the system, because any one little piece can mess up the rest of it all the way down the chain. So the more checks and balances, the more validations that you have, the better chance of having a good allocation come out the other side. All right. Going to take us through our gathering system there, Bill?
So what pictured here is just a typical gathering system that we may see for allocation. We start on the left-hand side. We'll see at the field level, this could be wells, it could be fields, it could be different injection points into the actual system. What we have here is reflected in a multi-tiered system where we would actually have the well pads that are next in the diagram, and we would allocate those flow meters. That's what FM is going to stand for here. We would allocate those flow meters back to the well level or the field level, A, B, and C. And then ultimately, at each one of those flow meters, we'll have a volume and specifically probably an analysis also. Anywhere we can allocate with analyses and actual metered volumes, we like to do that. And then ultimately, at the well pad, the A, B, and C are commingled together, and they simply flow into a central gathering facility. So any allocation that would take place at the well pad level would then feed directly into the central gathering facility. And then the central gathering facility would be allocated based on our oil and water and gas, as well as phase change in all of those different areas. Flowing gas into a slug catcher there at the top, we would realize a gas, but we also would realize a retrograde liquid or a pipeline condensate, if you will, that is then commingled into the oil system, flowing through a heater treater, and ultimately into a stock tank. Noting that when we go into that heater treater and the stock tank, we do have vapors that continue to be liberated from the oil. Those are then commingled with any produced gas that we see at the slug catcher, ultimately in a dehydrator, and then made available for sales gas. During any of this process, we are consuming fuel gas. That fuel gas would be used to fire the heater treater, for example. It could be used to power the VRU or any compression that we may have at the gathering facility. And then ultimately, all of those dispositions would need to be allocated based on either throughput, or they could be allocated through some contractual system that the contracts may certainly spell out. Of course, any consumed gas would also need to be allocated. That fuel gas we've already mentioned. The flare gas would be the other. And then ultimately, we would be allocating sales gas. Normally, that would be on a compositional basis. And then an oil sales that we would certainly be allocating back to metered oil at the well pad level. And then, of course, water disposal, which is becoming more and more prominent, especially in the onshore environment, and the need to allocate those fees, if you will.
Yeah, it's becoming more a
Yes.
commodity than a nuisance like it was years ago.
Correct.
Yeah.
This gathering system, the diagram that you see is sometimes also called as the allocation flow diagram. And we generally map it out using process flow diagrams, piping diagrams, and any other information that is not in any other diagram.
That is correct.
And so this is the starting place. And so when you all are starting with your drawing of your gathering system and you're trying to put your allocation together, there are a couple things on here that you want to also look at. So when we look at the heater treater and the VRU that Bill pointed out, notice there's no meter indicated there. Well, is there a meter? You may need to find that out. If there's not, going to have to come up with some way to estimate not only the volume, but the energy that's coming out. Both the heater treater and the VRU are going to be a lot higher heating value than the gathering line that they're being delivered into. So you have to figure out some way to add that up and contribute and allocate that accordingly, because that is oil-borne, not gas-borne. When we go back to our well pad and you look at your flow meters coming off of there, if we have gas lift, let's say, is that gas lift, is it taken off and metered before our meter leaving the pad or after? That's going to make a difference as to how you're going to allocate that and how you're going to account for it. So there's lots of little parts and pieces that go into this that you're going to have to determine in order to, as Bill said, custom fit the allocation model to your exact system. Do you agree, sir?
And this is where the application of PSM comes into picture, where there's not a quantity that is metered, the PSM can predict that
That's
quantity
correct.
in the system.
All right. Well, we have a ton of different fluid types. As Bill went through that process flow diagram, he talked a lot about where those come in, but just things to keep in mind. You know, you've got your gas sales, your oil sales, your natural gas liquids. Then you have your pipeline condensate. Bill mentioned about that, about how we have to watch out and make sure that we account for that accordingly. Fuel gas, flare gas, where's that coming off? How is that being measured and or estimated? Produced water, as we mentioned, that's becoming more and more of a commodity than a nuisance like it used to be. You look out in West Texas and it's 3-to-1, 4-to-1 water to oil. So really we're producing water and we get a little bit of oil as a byproduct. So that water is important. There's a lot of money exchanging hands to dispose of that water. And then of course your recycled fluids, gas lift, pigging operations, those things that have to be accounted for properly. So each one of those, you have to figure out how that fits into your system, how it's accounted for, and then how it fits into your allocation. Okay, let's look at oil. So what's involved in our oil allocation? Of course, Z mentioned shrinkage when he was talking about the PSM modeling. You get shrink off of that oil as the light hydrocarbons are liberated out of it. BS&W, sediment and water. Any meter factor corrections for the meters that are measuring that oil that goes through, flash gas analysis for what's coming off of there, and then of course pressure and temperature corrections. And you take a look at the little video that we have on the side here. This is a natural gas liquid, but we're using it to depict an oil. It's clear if you can see it. Right now it's under pressure. It's a pressurized hygrometer. We open up that valve on that puppy. Soon as it opens up, those light gases liberate off of it. And so what this is doing is this is showing you what happens as you change pressures and temperatures throughout your system and how your volume of hydrocarbon liquid changes throughout that system. It's much less now in the end, now that we've opened that up to atmosphere. So you've got to account for that in your allocation, make sure that it's allocated appropriately, who delivered it, you know, based on the quality of the oil, it's going to liberate different amounts of light hydrocarbons. And so depending on who's delivering that oil, you've got to make sure that it's accounted for appropriately. Then you've got to adjust for inventory changes and circulated volumes, of course, in your allocation. Bill, you want to take us through the audit trail, sir?
Sure. So this is just a representation of how we would essentially account for those factors that Dave was just mentioning. In the totalizer reading section that you have on the left-hand side, we are calculating what's known as an indicated volume. And those indicated volumes here are calculated based on readings from a totalizer, an opening reading and a closing reading. You'll notice that in this case, we actually have 2 meter runs, the top section being the first meter run and then the bottom being the second. You'll notice that those are split on a given day, and that is actually due to the meter factor, where we actually had a meter factor being determined, and then there was a swap out of that meter. And those meter factors, of course, are directly related to those indicated volumes. So we have to split those indicated volumes at the time of the new meter being installed. In the adjustment section, we have a blow-by noted. This would represent when we have gas that's carry under into the liquid meter and thus overspinning, in this case, a turbine meter, and the adjustment for that. We may have some adjustments there also in the adjustment gross that could be due to a variety of things. Maybe the meter froze, or maybe the meter stopped counting for any number of reasons at any given time. All of those types of things need to be brought into account when we talk about adjusting the gross meter readings, ultimately to calculate a net. In the factors section, you'll notice that we have not only the meter factor, but the water percent. In this case, 0.18 came from a composite sample, which is what the C will represent. And then we have a shrinkage value that was either determined, could have been determined by a process simulation model, could have been determined by physical shrinkage that happened in the laboratory, or even in the field if need be. And of course, right underneath that shrink factor, you'll see another factor, and that's the temperature factor, or the CTL, essentially corrects those volumes down 60 degrees. Ultimately, when we take totalizer gross, multiplied times all of our meter factors, we will calculate a net condensate barrel. And that net condensate barrel represents what that liquid would look like at sales conditions. Off to the right, if we continue, these are factors that could be calculated due to contractual issues or any of the sort, where we need to know how many net water barrels actually was metered through those turbine meters. We calculate, for example, a transportation barrel. A lot of times in the gathering systems, they charge transportation based on a high pressure barrel, and that simply is just corrected and the shrink backed out of it, if you will, in order to calculate how much it is at a high pressure liquid. And then of course, flash gas basis, in this case, this is a barrels lost to shrink. That's the amount of barrels lost to the shrinkage factor. A lot of times we will use that to allocate flash gas in a given system. So this is, like I said, just an example of a liquid audit trail, calculating everything that we may need from the liquid meters and the associated samples in order to perform our allocation.
Yeah, and remember, as we kind of mentioned, everything has to be defensible. So as Bill walked you through this audit trail is what you would use if you ever got questioned by a third party or that type of thing. You could walk them through their allocation. They could recreate it and redo it and show that you did it appropriately. Right.
This is quite simply just the condensate allocation. If we look at the current production values in that first column of numbers, that represents the theoretical number that would have been calculated on the audit trail that we just went through. You'll also notice that the top line has a retrograde value. That is the amount of retrograde that was calculated in the system that actually came from the gas. It was injected as a gas, was liberated, but then realized at the LAC unit as an oil volume. That is a theoretical number, just like all the other numbers that you will see. Typically, when we perform these types of allocations, we always start with the total amount of sales through the system. The total of the allocated sales column, 124,732, represents the LAC unit volumes. If we walk toward the left, the closing inventories is the total amount of closing inventories identified at the end of the production period. In this case, it's reflected as January 2019 up at the top. The opening inventory is the amount of inventory, of course, that was at the beginning of the production period. And of course, then we calculate how much production actually was received at the facility. So in this case, we received, when we take total sales plus closing inventories minus opening, we calculate how much production actually got to the facility. That's compared to our current production volume in the first column of numbers, and then allocated in this case on a pro rata basis in order to calculate everybody's corrected production.
We have a
Yes.
question. I think you touched on it, but how to correct oil from separator conditions to standard conditions and apply shrink and flash gas correction?
Sure. So previously, on the previous slide, we had an example of the audit trail that simply was where we were doing that actual calculation. It did not calculate flash gas. Normally, we will meter flash gas and then use our oil allocation or our oil netted volume and those factors that were calculated here on the right-hand side in order to calculate, or I'm sorry, allocate the flash gas itself. So this is a direct example of how we would do that. So we simply would take totalize our gross readings, multiplied times a meter factor, multiplied times the water percentage, and multiplied times the shrink factor and times the CTL in order to calculate the actual net barrels.
The shrink factor you get from one of two different ways, either from a physical shrink in the field where you're literally kind of doing what we showed in our little video. You collect a sample, pop the top, you have your starting and ending, get a shrink factor off of that. Or what's I think getting more and more commonly done is through process simulation modeling. You get a good composition of your product, and from that, then you can calculate what your shrink factor was from there.
So another question, how do you allocate for fluids when the composition is unavailable in a commingled system situation?
When the composition is unavailable, this is when we would use the physical shrinkage calculations that we did in the field or in the laboratory. We certainly have physical shrinkage calculations.
Oh, absolutely. I didn't think about it. Yep.
In the laboratory.
And in offshore, generally, we do have a composition, whether it's not periodically taken, but we do have historical analysis, for given.
Yeah, so normally in an offshore system, we are usually depending on laboratory generated shrink factors, these physical shrink factors that we mentioned. Normally when we get into the onshore systems, this is where we're depending on oil compositions, because a lot of times in the onshore arena, we're actually flowing that oil through stabilizer towers, heater treaters, stuff of that nature. So we have to simulate what that looks like. It's real hard to simulate that in the actual laboratory or in a physical shrinkage type situation. So that's when we're using process simulation models. So for most part, on the onshore environment, we're depending on those oil analyses for the start. Yes.
Right, we'll move on to gas. And so, what's involved there? Volumetric allocation on an MCF basis or MMBTU, as we mentioned earlier. Very rarely are we allocating on volume anymore. Typically, it is on an energy basis because no two gases were created equal. Then there's a allocation based on the component basis. So when you look at it, and you have those, obviously we've got rich gases coming down the pipe, and out of those rich gases we're going to have the condensate drop out, as Bill mentioned. And so when we have the condensates, we'll allocate that back based on a component basis to what theoretically came out of the gas. So we can break that down per component using the good compositional analysis, as we mentioned, and then take into account the phase behavior calculations, because we can have fun changes inside the pipe as we intermix products. Correct, Bill?
Correct.
So we have to properly account for that as we go through the system, not just what went in versus what came out. And then you have to do your volume adjustments for all the things that we mentioned before, fuel, flare, vent, gas lift's a big one. Recirculation gas buyback. Again, want to make sure to mention that the accuracy of all these pieces are crucial to your allocation model. Gas lift is what always makes me think of it. More often than not, you're not getting good pulsation dampening coming off of that gas lift compressor, and it's throwing off your measurements of your gas lift. So now that's in error. And so then that error just reverberates through your allocation all the way down the system, as will any error So it's all a balance of good, accurate measurement and analysis fed into that model. And then we get our gas volume statement. Gas volume statement takes our volume. It takes the heating value calculated from the composition of your gas, takes that heating value and volume, and it calculates an energy. And then we get our total energy for a given settlement period, typically a month. And then that's what we use in order to perform our settlements throughout there. Bill, anything to add to that?
No, other than, you know, measurement is a very important part, as we've tried to mention. Any mismeasurement is going to affect all other measurements on the system when we talk about an allocation system.
Right. Okay. All right, and so we've been harping on it, so let's go ahead and talk about it. Accurate analytical, of course, is a big piece of it. As we mentioned, we trade things on quality and a per component. You know, oil is traded on a quality and API gravity, BS&W number, all of that goes into it. Our gas is traded on an MMBTU, so we've got to have an accurate composition to calculate that heating value. Inaccurate analyses lead to inaccurate allocations. There's no two ways around it. Just like inaccurate field measurements, your volumetric measurements will do that as well. You need to know your speciation requirements. And so what are you settling on? You're settling on a C5 on your oil. Well, that's all fine and dandy. But what does C5 mean? When you look at that C5 plus, that C5 plus can be 80% of the composition. And so, great, we can't just apply normal pentane physical properties to it. We've got to know what the physical properties are of that plus fraction in order to properly put that into our allocation model. What are we going to, gas? Gas ordinarily goes to a hexane plus. What are we going to split that out? You usually do a theoretical split on your hexanes plus. The standard is 60-30-10, which was arbitrarily discovered, but actually works pretty darn good. Or are we going to do something more extended, a C9? What are you going to be using it for? You need to know what you need to have speciation-wise and what you need to have physical property-wise to feed this model to make it as accurate as possible. NGLs.
NGL allocations, many ways of doing NGL allocations, GPM based, energy based. You know, a lot of times when we're allocating NGLs, we are having to not only honor, you know, typical allocation algorithms, but also we have to honor contractual issues, whether or not, for example, that we are going to be allocating on a percentage of liquids basis, or whether or not we have fixed percentage calculations of recoveries, or whether we're going to actually allocate the actual recoveries from the system. So NGL allocations, of course, are becoming more and more prominent everywhere, simply because of all of the different commingling fluids that we may be commingling upstream of any NGLs that we're allocating. This goes back to having accurate allocations based on analysis. Again, so analysis is very important at this point.
All right, so let's look at how we're going to develop the workflow for putting together that allocation. Z?
So our standard workflow can be divided into 4 stages: review, discuss, identify, and contingencies. During the review stage, generally when a client approaches us, we ask for all the documents. Then those documents are your PFDs, are your process flow diagrams, your piping and instrumentation diagrams, your PHA is your production handling agreement, your commingle approvals, any commercial agreements. And once we've done a thorough review of all these documents and the diagrams, then we will first make a map of the allocation process.
I just wanted to say, Z, that you know, because a lot of people on the phone, it's acronym overload in the oil and gas industry. They love it to death. And so PHA is your
production handling agreement.
not a process hazard assessment. So let's make sure, because that's going to be what a lot of people think. So just always make sure first what your acronym means, and then you'll know how to apply.
Thanks.
No, it made me giggle, so I had to say something.
So once we are through the review phase, we go to the discuss, where we will discuss all the field operations pertaining to the system, overview of the system, what are the measurement practices, how are your meters installed, what type of meters are installed, and what is the complexity, overall complexity of the allocation is going to look like. Now, once we've discussed that, then we identify the roles and responsibilities in the organization. And the organization could be from an SPL perspective, we are the allocator, and who is the contact point in the operator side that the data that we are getting from. Will you want to just enlighten on that a little?
Yes, it's just simply at each point in the allocation, we have roles and responsibilities that need to be identified. Who's going to be responsible for getting raw data to the allocation? Who's going to be responsible for populating that data in any way? Who is responsible for ultimately approving all of the allocation processes that go along, and then ultimately going into marketing, and who needs those results, and how will they be used, and make sure they are interpreted correctly.
And contingencies is when, let's say there's any modifications in future, we are scaling up, scaling down, how do we handle all those facility modifications in our allocation system? And is the production, if when we forecast the production, if that is going to impact our allocation, things like that.
This goes back to constant communication with all the players in the allocation process, tracking those facility modifications, making sure that we're proactive in identifying those instead of having to react to them. Is the best way to handle those types of things.
Perfect. All right, although it's not part directly of the allocation process, we want to talk about the measurement data editing piece because it's a critical part. As all that data comes in from your SCADA system, it's got to have a way of being properly verified, analyzed, and then transmitted into your other processes like your allocation system. You want to make sure that it's using the proper calculations to ensure that you're getting accurate volumes. Those change periodically. You want to make sure they're there. You want to make sure that you've got good exceptions and good validation set into your system, so when something does go out of whack, some of you are getting thousands and thousands of meters coming into your system with hourly data for each one. An analyst can't pick through that data and catch stuff. So you need a system that helps you to figure that out and determine where your issues might be so you can catch it up front instead of it making it all the way through your allocation process. And then that looks funky and you've got to rebook the whole thing because time is money. And so if you've got your allocation department's got to go back and reallocate, which happens routinely anyway, let's be honest, a lot of times you're allocating on theoreticals because you don't have all the information that's come into the system yet in order to do your actual allocation, but you want to minimize how often you have to do a reallocation. So your measurement data editing is key in this in ensuring that you get it. And that comes into building your volume statements. Your electronic diskette deliverables are important because if they're not set up properly, they don't import in the system correctly. You may not know that it imported incorrectly because it may just be something in a wrong field that populated incorrectly. SCADA issues come into play here where you're actually receiving data from the wrong meter. It goes on and on and on and on. It's just an important part of the process to make sure it's as correct as possible.
Yet another question. So is allocation generally standardized by government regulations or is it fit for purpose?
Again, it all depends on, to some degree, yes. I mean, our regulatory agencies do play a role there. But again, everything is fit for purpose and built based on the research or the building of that allocation system, reviewing all the flow diagrams, all the commingling points, all the measurement points.
But for instance, GLO wants things commingled a certain way, right?
That's correct.
And BLM and
the allocations have to be able to react to that.
Right, right. Yeah.
So that was the usual answer of yes and no.
That's correct.
Which is always the answer in the measurement world. Z, you want to tell us about production data surveillance, sir?
Production data surveillance is more of a proactive approach, so that you're always tracking your system. When you're in operation, make sure data is validated during the month rather than after the month. Example could be, let's say you're checking your wellhead rates versus your separator rates. If you have a meter on the wellhead, if not, let's say if you have a VFM, virtual flow meter, how is that trending? Are you trending your GORs? Are you tracking your proving and sampling frequencies? And so on. So if you are proactive in the surveillance part, that helps you minimize any anomalies, identify any anomalies in the raw data. It will help you pinpoint any causes in the system imbalances and ensure all the data that is fed into your allocation system is validated. So when you run the allocation is correct, and you don't have to go back years to months and change the allocation numbers again. And that opens a whole lot of can of worms problems for companies. And that is generally companies try to avoid misallocation. So data surveillance is, we see a lot of companies doing that, where they will have their own team validating the data, and then all the data is already validated and filtered before it is passed on to us. And the chart that you see is what happens when your data is, let's say, not validated, but it is a loss in the system. What you see is like over the month, like over the period of 1 year, you have oil loss compounding to like over hundreds of thousands of barrels. So this, would you call it a lost oil? Unaccounted for. This is unaccounted for oil. Lost and unaccounted for oil.
So Z, you would say that this is more of a real-time approach to
Correct.
minimize or zero in on the imbalances to correct them before the end of the month when everything piles up. Okay.
Yeah, because those imbalances, especially on the oil side, well, maybe not at $12 oil, but at $50 oil, that gets up to the E-suite really fast because those imbalances add up to big dollars.
Right.
Doesn't necessarily mean, and typically doesn't mean that it was lost. It just hasn't been properly accounted for, but that gets people really excited really fast.
So I think this is an area that gets overlooked.
I agree.
It
does. Yeah.
Value add that could be provided inside a company.
Yep.
Yeah.
Great point. All right, just to give a look here, just at what misallocation can cost you. Of course, we're looking at $50 a barrel here. Don't we all wish that's what it was?
I'll take 30.
Take 30? Okay, fair enough. And so, but you can look at, this gives you a cross there. So if we look at 0.5% of error and it's 6,000 barrels a day, that's $540,000 loss. And so just on and on, the bigger the error, the larger the volume, the more money that costs. And realize that this chart may look kind of vague, but I can tell you, having been there, that it adds up really fast. And so when you have misallocations, when you have errors in your measurement, it can mean that somebody really is losing a large amount of money that then has to be figured out, and somebody's got to, get an adjustment for. And adjustments, it may not sound like much because you say, okay, well, really, we really did owe them that $4 million, so we're just paying them that $4 million. But there's a lot of human hours that go into recalculating that dollar and reissuing. And it's not just one location. An error in this spot that you have to reallocate for now trickles to all the allocations and all the partners and interest owners and all of those folks that are involved in it. And so now you've got to reallocate to everybody, which means you have to tell some people, we paid you a little bit too much, so we're not going to be paying you for the next couple months. And that it really becomes a mess. So the more you can dial in to begin with, the better it is for everybody. And just a graphical depiction of this, saying the same thing. The greater the loss, the greater the volume, the greater the dollar it adds up to. So that's what we had. Hopefully you all got your questions in there. If you didn't, feel free to send them over in the next few days.
Well, thanks, Dave, Bill, and Z. I think that was very informative. We appreciate that today. For those out there, we'd like for you to visit us at our website, spl-inc.com. If you have a question, you can contact us via the website on the Contact Us feature. But also, we'd like you to follow our company on LinkedIn. So look us up on LinkedIn, follow us. There'll be more to come, and also reach out to us individually on LinkedIn with any questions that you may have. And thank you for attending today. We appreciate it.
Thank you very much. We'll see you on the next one.